period. So if you haven't checked PowerSchool, you can feel free to check those out a little later. Two students that need to make them up. So hopefully Thursday I can get those back to you. And then like the last portion of this chapter is on matrices, which you did a little bit last year in geometry when you were doing a dilation. So a dilation is when you're changing the size of an object. You're making it bigger, you're making it smaller. And you would have done them with matrices. So we're going to review basic matrix operation today. On Thursday, we're going to do multiplying matrices. So how can you take two matrices and multiply them together? And then on Friday, we'll solve equations using matrices. So I'm going to show you how to use matrices to solve equations. That's it then for the rest of the chapter. So like 3 different sections, a day on each section. So that means next Tuesday, even with a short week that we have this week, you'll have a test on chapter 3. So that'll include substitution, elimination, graphing, and also the matrices. So that's why I do want to get those tests back to you, the quizzes from Friday back to hopefully by Thursday. So does anybody remember what a matrix looks like? So a matrix is an arrangement of numbers. And it's in like a little box. And that box is called a matrix. So a matrix can have different numbers inside of them. And they're arranged by rows and columns. So arrangement of numbers by rows and columns. And we'll look at matrices of different sizes, bigger and smaller. So a row goes left and right. So here would be row 1, here's row 2. A column goes up and down. So think of a column holding a building up. A column is vertical. The Colosseum has a whole bunch of vertical pillars. So a pillar is something that holds up a building. A column are the ones that go vertical. So A and C would be considered column 1. And then B and D are considered column 2. So rows go left and right, columns go up and down. Columns are what holds up buildings. They are vertical. If they fall down, the building collapses. So each matrix has a dimension. The dimension would be the size of the matrix. And it's literally given by the number of rows with the number of columns. And that little X is the word by. So this matrix here is a 2 by 2 matrix. So we're not multiplying. That little X is the word by. So the size of the matrix we say is 2 by 2. 2 rows and 2 columns. Or 3 by 2, 5 by 2, 7 by 2. The little X means the word by. And then the last term up here, an element, is each piece of the matrix. Or it could be a number. So there are 4 elements in my matrix. A is in the first row and the first column. That would be element number 1. today we are going to try and add, subtract, and multiply by a constant number. So we're not going to multiply two matrices together, but we're going to see if we can multiply by a constant. But we're going to look at add, subtracting, and multiplying matrices. This is meant to be really straightforward. So when we're adding a matrix, we're kind of just looking at one matrix and adding it with another one. And as long as you can add, you should be able to add matrices together. So the little directions say to add or subtract two matrices. Simply add or subtract the corresponding elements. So that means if they're in the same position, then you can add them together. So a matrix with position 1, I can add with a second matrix of position 1. They gotta be in the same location. You can add or subtract matrices only if they have the same dimensions. So they have to be the same size. If they're not the same size, then you cannot add them together. Because you're adding the elements together, and if they're not the same size, then you wouldn't have enough to add with a different matrix. So they must be the same size in order to add or subtract them. So if you look here, kind of giving you a little example. So element A gets added with element E. Literally, we're taking A plus E. They're at the same place. They're the same position. F and B will be added together. And then C and G, and finally D gets added with H. So the same place, you're adding them together. That's how you create a new matrix. So matrix addition is just taking two numbers, adding them together as long as they're in the same place of the matrix, or subtracting them. So if you look at the first example, it says add and subtract the matrices. So in letter A, we have 6, -2, 1, and 3, and you always move across the row. So 6, -1, then you move down, 1, 3. We're subtracting that with 3 and 2. What do you think you would do with letter A? Huh?
You can't combine.
Why not?
They're not the same size.
Yeah. So they're not the same size, therefore you cannot combine them. They must be the same dimensions in order for us to add or subtract them together. So letter A has 2 rows and 2 columns, so that is a 2 by 2 matrix. Letter B has still 2 rows, but it only has 1 column, so they're not the same size, therefore you cannot combine them together. So if you look at letter B, can anybody give me the dimensions of letter B? Julian. Yeah, this is a 2 by 3. This is also a 2 by 3. So 1, 2, 3 rows. How about the other way around, Julian?
3 by 3.
Yeah. Here we go. 3 by 2. So 1, 2, 3 rows, 1, 2 columns. So rows first and then columns. So 3 across, 2 down. So when you add them together, you're adding each piece. Your end result should still be 3 rows and 2 columns. That's not changing. So you're going to take -2 and add it with 1 because they're in the same location. They have the same position. So -2 plus 1 makes -1. And then you're going to go to the right. So do the row first and then move down. So now we're looking at 1 minus 4. Well, 1 minus 4 is -3. So now we've added the first row, each element together. And then you move to the second row. So Eden, if we look at the second row, what do we get for the second row? -2 and 12. So second row, we have 0 with -2, 3, and none. And then Emily, how about the third row? Emma, I'm sorry. Emma, how about the third row here? 8 and 11. So here's our 7 and 1, the 6 and the 5. And that's it. So a matrix is an arrangement of numbers. Yes, there are many things you can do with matrices. I actually took a whole class in college on matrices. We're just skimming the topic right now. You'll be using different applications of it through the rest of your mathematical career. Whole class in college on matrices if you want to take a whole class in college. This is it for now. Questions? So you don't add all these numbers together. Each piece stays separate because it represents a piece of the matrix. Questions? So the next one says multiply a matrix by a scalar. A scalar is just a whole number, or in this case an integer, that's outside, that you want to multiply everything inside with that number. So when you did dilations in geometry last year, did I skip a problem? No. When you did dilations in geometry last year, you would have had a number that you're multiplying each of the vertices by to make your polygon larger or to make it smaller. So this -2 has to be attached to every number inside. So literally whatever's outside, you're going to multiply that number by every piece of the matrix, every element of the matrix. So in this case, we're multiplying everything by -2. So Will, if you multiply everything by -2, what do you get?
-8, 2, -2, 0, -4, -14.
Thanks, Jeff. And then letter B has like 2 steps here. So we have the multiplying by 4, and then we're adding them together. Order of operations says you have to multiply before adding or subtracting. And that goes with matrices as well. So you need to multiply everything by 4 first, and then add those 2 matrices together. These matrices are the same size, so we are allowed to add them together. So Melanie, if we multiply the first one by 4, what do you get?
-8, -32.
Good.
20 and 0.
The second one doesn't change because it doesn't have a number in front of it. So it stays as -3, 8, 6, and -5. So only the first one is changing. It's being multiplied by 4 because it has a 4 attached to it. And then we add them together. So Abby, when you add those together, adding the corresponding elements, what do you get?
-5.
So we have a -8 and a -3, both negative. -11.
24.
Okay,
26.
good. Nice job. So that would be our resulting matrix. So multiply first, add the 2 pieces together. Questions so far? Alright, so this next one is a little different because now we're trying to apply some equations with it. And it wants us to solve this equation. There's an x and a y in it, so we're going to try and see if we can solve for x and y. Outside of the matrix, both of them, is a 3. So because there's parentheses around both matrices, this 3 needs to be distributed to each piece of the matrix. So see if you can do that part first. Distribute the 3 to everything. So multiplication. We'll distribute the 3 through. Get rid of the parentheses. Julie, if we multiply things by 3, what do we get?
15x, negative 6, 18, negative 12, and then 9, 21, negative 15, negative 31.
So there's an addition sign, everything's been tripled, multiplied by 3. Now we'll add the correct pieces together. So just like if you had an equation, you would add the corresponding like terms together. So we're going to do that same exact thing here. So let's add like terms together. Not really doing anything with the other side of the equation yet. The other side of the equal sign, just kind of working on the left side. Mackenzie Myers, what do you have when you add these together?
15x plus 9, 15, 3, and negative 39 minus 12.
So 15x plus 9, because the x and the 9 are different, just like terms, you can put a plus sign in between them to try and combine them together, but you physically can't add those two numbers together. Alright, so the problem wants us to solve for x and y. How do you think you'd solve for x and y? So we did all the combining that we could possibly do. We distributed a 3 through, added the things together. How can we find x and y? Julian?
So you have like 15x plus 9 equals negative 21?
Yeah. So the element in the first one has to be equal to its corresponding element on the other side. So that means 15x plus 9 is supposed to equal negative 21. If you look, the 15's here are already matching up. The second row, first column, matches up with the second row, first column. Same thing with the 3. The 3 on the bottom here matches up with the 3 on the bottom. That has to happen for the matrices to be equal to each other. Each element should be equal to the element on the other side of the equal sign. So we can set up a couple of little equations here. 15x plus 9 is equal to negative 21. And then the second one, we have negative 3y minus 12 is equal to negative 24. So using the matrix, we can create our own two equations to solve for x and y. Now you're solving for them individually because they each represent a different piece of the matrix. So subtract the 9. And you should find that x is negative 2. So that means if we plug a negative 2 in, 15 times negative 2 is negative 30, plus 9 makes negative 21. I get that negative 21 on the other side of the matrix. We would add 12 for the second one. And y should equal positive 4. Again, if we plugged a 4 in here, we would get a negative 24. So negative 3 times 4 is negative 12, minus 12 makes negative 24. So matrices need to be equal to each other. Each piece in one matrix should equal the other if there's an equal sign in the problem. They should be equivalent. So I believe there are 3 other problems at the bottom of your page. You can just make these into big bars. For some reason they did not connect together. So the first one is subtraction and the second one is multiplication. And then the last one is another little equation. Kevin, what do you have for number 1?
For 3,
So 3 and then,
negative 3, 2.
Oh.
Add 3, number 2, sorry.
no, what did you have? Did you have negative 9?
No, number 1, I had negative 3.
Okay, so if it is negative 6 and then it's a minus 3.
Negative 9.
Yeah. Okay, and then
2.
2.
Negative 8.
Yep, that's right. Negative 8, and then your last one was,
Negative 6.
careful with the minus negative.
4.
There you go. So just be careful with the minus sign. Make sure you're subtracting them and not adding them. So negative 6 minus 3, 2 minus 0, negative 1 minus 7, negative 5 minus negative 1. Questions with number 1? Maggie, how about number 2? If we're multiplying everything by a negative 3.
3, negative 1, 6, negative 12, negative 6, negative 27, 18.
What are the dimensions of this last matrix here? How many rows, how many columns? What would the dimensions be? Julia?
2 by 4.
Right, so 2 rows, 2 big rows, 4 columns. 1, 2, 3, 4. So that would be 2 by 4. 2 rows by 4 columns. Any questions with 1 or 2? So the last one is the little equation. We're asked to find the x and the y. So this is one that we have a little bit of work to show for. What would you do first? Holly, what do you think you'd do first for number 3?
Distribute negative 2, so piece of both equations.
Okay, so what does it become when you distribute negative 2?
6x 2, negative 8, negative 2y, negative 18, 8, 10, negative 6.
And the other side does not change because it's not inside of parentheses, so it stays as 12, 10, 2, and negative 18. Brandon, what's next then? And what do you get when you combine the left side?
6x minus 18. 10. 2. And negative 2y minus 6.
Again, that should match up with the other side. So make sure the 2 elements that you do know, without the variables, that they're matching up. Would you get the same answer if you added these 2 together first and then multiplied by negative 2? So could you have added the inside parentheses first, taken that answer and multiplied everything by negative 2? Would that give you the same answer? It would. So if we decided to take negative 3x plus 9 and add them together first, and then multiply by negative 2, you'd get the same exact answer. So if you want, you can add things together and then multiply by negative 2, or you can multiply by negative 2 and then add, but you would get the same exact answer either way. So then the last step would be to solve for x and y, making sure you're solving for the correct element, so matching the elements up. We have 6x minus 18, which is equal to 12. And then the bottom right here, negative 2y minus 6 is equal to negative 18. So matching the element of the first one with the element of the second one, making sure you're matching those corresponding elements. So Maggie, what would you get for x? Yeah. So we end up with 6x equals 30, and you get 5. And then Maggie, for the other one, you ended up getting?
6.
So adding the 6, negative 2y equals negative 12, so y is equal to 6. Questions? So hopefully fairly straightforward. There's still some time. We've got about 7 minutes. So you can come over, grab a book. I can display some of them up here as well. But we still have about 7 minutes to get started on this. Please write down the original problem. I realize some of these will not have work, but you should have the original problem down. And then the matrix that you're getting, your solution matrix. And I can display some of these up here on the smartboard for you. So on the board back there, we have page 191, and we're looking at 5 to 29 odd, and then 33, 37 to 47 odd. 37 to 47 odd is a mixed review. So getting you to remember about solving equations because that information isn't going away. But I can put a bunch of these up here on the projector. I'm thinking you can get at least a couple of them done. Again, please write the original problem. So the first one says perform the indicated operation if possible. If it's not possible, make sure you're saying why. So if they cannot be combined together, you would say the dimensions are not the same. One is a 2 by 3, the other one's a 3 by 2, whatever that happens to be.
Please pardon the interruption. This is a reminder to all seniors, the senior class photo will be taken tomorrow at 10:15. That's 10:15 tomorrow. The senior class photo will be taken. Thank you.
Anybody interested in doing 27 or 33 for Thursday? Mackenzie, 27. Oh, 30.